Hello, everyone. Our guest today is Carlo Rovelli. Sir, thank you for accepting our request and coming. It's really nice to come together with you at such a beautiful event on the first day of the new year.
Thank you, Berk. Thank you for having me and for putting this together, and Happy New Year.
Thank you. First of all, I would like to mention your new book, Helgoland. If I am not mistaken, it came to about 4 to 5 months ago. Can you talk about the content of the book?
Helgoland, it came out in Italian a few months ago, and it's gonna be, here it is.
Yes.
And it's gonna be published in English soon. It's not out yet in English. It's gonna be published in March. And it's a book about quantum theory. It's a book where I try to...
It's mentioned the Heisenberg. It's
That's
true?
right. That's right. It's a book where I try to make sense of quantum theory. And Helgoland, the title, and is this island here. It's a little island in the Northern Sea, very rocky and very solitary with no trees, where Heisenberg went in 1925 alone. He was 23. And how old are you, Berk?
I am 17.
Okay, so you still have a few years, but not many.
Yeah.
You have 6 more years. He was 23 and he invented the quantum theory there. He made the key step toward quantum theory.
It's very interesting. And I want to continue with a nice quantum question. Although we use quantum mechanics in every field, there are still aspects that surprise us. Do you agree with Einstein's idea that this theory is not yet complete?
No, I do not. I think that the question is very correct. We use quantum theory in so many fields, and we utilize it all the time. But we're still confused about it. But I think it is because it's very radical. It changes our view of reality. And that's what I discuss in the book. I think we have to get used to it, and we have to learn what is really telling us. So I would rather agree with Bohr, who long debated Einstein precisely on this point. And Einstein, somehow he recognized the importance of quantum theory, of course, but thought that it had to be changed to be able to understand it better. So something was missing. And Bohr reacted by saying, no, this is the strangeness of nature. We have to understand nature in its strangeness and change our mind to be able to understand it.
Yes, okay, thank you. And the other question, can you talk about your loop quantum gravity theory and what are the differences that distinguish this theory from the string theory?
Yes. Let me start from the second part of the question. There are two kinds of differences. First of all, string theory is an attempt to finish physics and have an overall encompassing theory which everything falls from it. Loop quantum gravity, no. It's just a theory of the quantum aspect of gravity and the quantum aspect of space-time. So it's not a unified theory. However, I think it's much more complete and developed, loop quantum gravity, than string theory for what concerns quantum gravity. Because string theory, one way or the other, is not a complete theory for the moment. It's very patchy. And we don't understand it well. And it's not working very well because it has predicted a lot of stuff which we have not seen. For instance, it has predicted supersymmetric particles at CERN, and they were not seen. Loop quantum gravity, it's more focused. It's just a quantum theory of gravity. And what it predicts is that space in which we're immersed is not continuous. Is as a granular structure, like the electromagnetic field is made by photons, particles.
Yes.
So space itself is like particles of space, quanta of space. But, and this is the key point, these particle space, this quanta of space, these grains of space, are not moving in some space. They are space themselves. They constitute space. So there's a quantum aspect of the space in which we're immersed, which is well described by the mathematics of loop quantum gravity. And I think the current status is good. The theory exists in a number of versions. It's well founded. It has a good philosophy, a good basic.
Yes.
We understand it. And what we need, what is missing, it's some empirical verification, some predictions that will be verified. So the theory is still a tentative theory because we don't have empirical support, but it's a possible theory of the world.
Yes, thank you. And do you believe that the theory of everything? Are you believe the theory?
Look, I think in any case, we're very, very far from a theory of everything. So I don't think it is in reach for us. I mean, maybe, who knows about the future? I mean, I don't know the far distant future. I doubt that we will find a theory of everything in the sense of in which some physicists have looked for it. For the moment, I mean, we don't know what is dark matter. We don't know what happens at high energies. There's so many things about the universe that we don't know. I think very often in the history of science, scientists thought to find the final theory. But that's not the way science works. It's never the final theory. It's one step more in understanding nature. And then one should be able to do this step. It's great, it's fantastic. But then there will be another step and we understand it even better.
Yes, okay. And I would also like to mention the relationship between physics and philosophy. But both physics and philosophy in your books are in perfect integrity. I am particularly impressed to buy your Anaximander book. But there are those who think it's wrong to use physics and philosophy together. Could you talk about the Anaximander book and the physics-philosophy relationship?
Yes, let me start by Anaximander because he was in Turkey.
Yes, I know.
Yeah, I mean, it was definitely, now it's Turkey. Miletus, it's a city in the coast of Turkey on the Mediterranean Sea.
Yes.
It was a city settled by Greek colonists. But it had relations with the kingdoms of Lydia, which were in the central part, in the mountains behind the coast. And Anaximander, I think it's a major thinker, and I don't think it's fully recognized because he was a pupil of Thales. And sometimes in philosophy book, he's presented together with Thales and with Anaximenes as a Miletus school, as the beginning of philosophy. But I think this school did much more than that. It started also the process that became science. In some way, one can say it was the first philosopher and the first scientist, maybe exaggerating a little bit, because many people you can say is the first scientist. But that's a moment in which a crucial step, humankind made a crucial step toward understanding nature and toward rational thinking. And he's the one who first understood that the Earth, the sky is all around the Earth, not just above the Earth. So the Earth is like a stone that floats in the middle of the sky around. He's a great character. He understood all sorts of things, and it started the naturalist approach to understanding the world, which today we call science. I think then coming to the first part of the question, what I think about science and philosophy, they are different disciplines. We cannot confuse the two. I mean, a philosopher asks certain kind of questions, discusses Science uses different methods, use mathematics, use experiments,
Yes.
investigates. However, in this diversity, the historical relation between science and philosophy has always been very, very strict, because philosophers cannot ignore science, because that's what we know about the world. But it's also true the opposite. Scientists cannot ignore philosophy. All the great scientists of the past, from Anaximander to Newton to Copernicus, Einstein, Heisenberg, all the ones we
Yes.
mentioned, Bohr, were all very much schooled in philosophy. They read the philosophers. And philosophy opens your mind, allows you to think complexity. Some scientists just do one narrow thing, but then you don't understand things in big. And Einstein, for instance, which is the greatest scientist of the 20th century, he read Kant, all the books of Kant, the three critics, when he was 15, younger than Newberg.
Yes.
He had read all Kant, and he read Schopenhauer, and he read Mach, and he read the philosophical books of Poincaré, Leibniz. So it was very, very important for Einstein philosophy, and the same for Heisenberg. So I think that the idea that these are separate investigations, it's wrong. The problem is understanding the world. And we don't understand the world well. We understand it a little bit. And we need some technical tools. We need experiments. We need mathematicians. And we need philosophers. And we need theoretical physicists. And it's a combination of all this work that go together, march together, and increases our understanding of the world, in my opinion.
Okay, thanks. And the next question, little bit personal than this question. How
Okay.
did you decide to become a physicist?
Oh, I decided very late. I was very curious. I was interested in all sorts of things, but not particularly in physics. When I finished my school and I had to decide at the university where to go. I did choose physics. In Italy, you choose your direction when you are 18. You finish high school and you have to choose which university to go. So I chose physics, but I was not very. It was just a little bit, throwing a dice on a little bit random, the choice. I was lucky because I went to the university. I was very involved in politics, in traveling, in being curious, in reading everything, knowing people, having friends, but not very much in science. And at the beginning, I was not doing my good work as a student either. I was late with my exams, but then at some point, studying for some exams, I said, "Oh, this is wonderful. This is beautiful." This is so beautiful, incredibly beautiful. When I started studying about Einstein and Heisenberg and relativity and quantum mechanics, I said, "This is magic. This is the most beautiful thing I've found." So I fell in love with this, and I was not your age. I was much older than you. Maybe I was 24. I don't know, something like that. And at that point, I loved it. I fell in love with it. And also I realized that I was good. I could do the problems. It was me helping my friends and not asking help from them. So I said, I'm good. I love this. This is what I want to do. And for me, it was also a way to be, being a scientist, you have a lot of freedom. You can think with your head. You don't have to wake up at some hour in the morning and go to work and say, "Yes, sir." You can be yourself, and that's what I love.
Yes. I also want to touch on the concept of the time, because our perception of the time has changed continuously for years, and it still seems to continue to change. What is the time, and how should it be perceived?
Well, you have mentioned a book I've written about time, The Order of Time.
Yes.
I think the question you ask is a complicated question. because the answer is complex. Time is not a single thing. That's the main message of my book.
And I ask one question again. Time is personality or the generally?
Okay, I understand what you mean. The answer is both, because time is not a single thing. When we say time, we just think, okay, time is time. We all know what is time. But that's wrong, because time is a complex notion. When we say time, we actually mean all sorts of things. Some of this are very much related to our own psychology, the functioning of our brain. Because when we say time, we really mean our memories of the past, our sense of the present, our anticipation of the future. And these are things which are in our brain. But of course, there is also an aspect of time which is not in our brain, is out in the world, is, clocks that ticks. But a clocks that tick doesn't have all the complexity of what we mean by time. And the way clocks tick, in our experience all together, right, all at the same rate, it's a very specific way, because if we know from physics that if a clock moves very fast, it doesn't tick at the same rate as the other.
Yes,
so there is no really common clock time. So you see, there's one personal time, emotional time. There's one time of our memory, perception. There's a time of the clock. But even that, there's a time beyond the clock, because all clocks go at different speed. And if you go to quantum gravity, where space-time has quantum properties, it's even less structured, the notion of time there. So if we want to understand what time is, we have to break it up in various layers and say, okay, this depends on my brain, this depends on thermodynamics, this depends on mechanics. This is only true if we forget quantum gravity. If you conclude quantum gravity is even something else. So that's the beauty of the problem of time. It has many layers, and we cannot answer the question, what is time period? We have to bring it apart.
Okay, and finally, do you believe in extraterrestrial life, and namely aliens? Do you believe the aliens?
Well, it's two different questions. It's not the same question.
It's the popular questions.
Yes, it's a very popular question. But once again, do I think that in the universe, far away in the universe, there are things like life on Earth, or even things like intelligence on Earth? Yes, I do. I'm not sure. Nobody knows for sure. But if I had to bet, I would say yes, I bet they are. Why? Because the universe is so large. It's really hard to figure out how big is the universe. I mean,
Yes.
our galaxy has what, 100 billion stars. And now we know that around each of these stars, there are planets, very much like the Earth. So there are 100 billions of things like the Earth. I mean, come on, it cannot be that the Earth is the only one that did something like us. And this is just one galaxy. And there are billions of galaxies out there. So the universe is so immense that to believe that there is something very specific that only happened on Earth, I think is foolish. I mean, of course, there are other things like us. Probably, careful, probably not exactly like us, and not like plants and animals and Turkey and Italy, very different things. Maybe they're, gas interacting, I don't know, electromagnetic and being intelligent. Who knows? I mean, nature has much more fantasy, imagination than us. So yes, I think there is all sorts of things out there. Now, do I think that there is a chance we can communicate to these things, on that some aliens could come on Earth and appear in a flying saucer? No, I don't. I think that all the flying saucers are total fantasy, total imagination. If there was another civilization communicating with us, we would know very obviously. And so I think that all the nonsense about UFO, unidentified flying objects and aliens arriving. That's silly. That's completely silly.
Okay, thank you, sir. Thanks for accepting to our request and coming. Thank you
That
so
was
much.
very nice. And thank you for these very good questions. And Happy New Year's to everybody.
Thank you, sir.